Alright, so now we're going to look at how to describe numerical univariate data. So, with here we're going to actually do something that you're normally told not to do in school, and that's cuss. Alright, so what do I mean by cuss? Well, first off, C is the center of your graph. So we needed to identify what's the center of our graph. We're also going to talk about what is unique or unusual about our graph. Okay. Next, we'll talk about the spread of our graph. And then lastly, we're going to talk about the shape. Now, even when we do all four of these, where we do talk about the center, something unique, the spread, and the shape, we need to make sure that our graph, our description, is in context to the problem. If it does not actually talk about the problem, then the person reading it won't actually be able to help. So we want to make sure everything that we describe mentions what comes back from that problem. So we talk about the W's, the who, what, why, when, where, how. Okay. All those ones come into effect. Alright, so let's look at this. What strikes you the most distinctive among the distribution of the exam scores in classes A, B, and C? So whenever I'm looking at this, notice that we have A grouped up close where that middle part is about 67. Right? B has it up to about 77, and then C is up to about 87. So really what's pointing out to me in this picture is where the center is. So what we're talking about with the center is discusses where the middle of the data falls. So that's when we're talking about center, we've got to talk about where the middle of the data falls. Right? There's three measures of central tendency that we're going to talk about and we can use for this. First is the mean. Right? This is used in symmetric graphs. Again, the mean is the average of it. So basically you add up all the numbers, divide by the total, and that's your mean. Okay. Whenever the graph is uniform, working out throughout the way where it's symmetric, kind of like there's a little bit of a curve to it, and equal on both sides, then that's the ideal central tendency that you're going to use. Now, the median is the number that's actually in the middle. If you line them all up from least to greatest, whichever one's the exact middle number is your median. Right? This is what you use for skewed graphs. We're going to talk about what a skewed graph is in just a little bit, but for right now, just remember, if we're talking about skewed graphs, we're going to use the median. And then the third measure of central tendency is the mode. Right? This one we are rarely going to use to describe the center. And it's not very helpful whenever we're talking about this, because it's more for if they're kind of all over the place, and so if something pops up more often than others. Alright, so it's not really a good measure of central tendency, but it is one that is technically available. Alright, so now let's look at this one. So what strikes the most distinct difference among the distributions of D, E, and F in this picture? So notice F goes wide. E kind of closes in a little bit more, but D is definitely all tight in there. So way close together. So what we're talking about here on this one is the spread, because you can easily tell the difference between how far these ones are spread out, the numbers. So second letter that we're going to talk about is S for spread. So this discusses how spread out the data is. Alright, it refers to the variability in the data, how far things can be from each other. Alright, so there's measures of spread that we'll talk about, but for right now we only got one that we really know. So that's the range. We take the maximum number and subtract the minimum number, and that's your range. Alright. The next measure is the standard deviation, which we'll learn about later. We don't really have the tools for it yet. You'll get it. We'll cover it soon enough. And then the last one is the IQR, or the interquartile range, which we'll learn later. Now, we have actually seen the IQR a little bit whenever we were doing box plots. Right? So where the box ends and we get to those whiskers, the top number on the box and the bottom number on the box. You take those and subtract it, that's the IQR. But again, it's not important at this point. Right now, we're just going to use the range. Okay, so we look at this next one, and now what strikes the most distinctive among the distributions on these exam scores? So, each of these graphs look different. Alright, for the first one, we've got most of the data to the right, and there's a little bit of a taper off going down low. Alright, and the next one, we've got most of the data towards the left, but there's tapering off towards the right side of it. And then the last one, it's kind of just curved with most of the data in the middle, where it kind of is spread and sprinkles off to the sides just a little bit. So what we would describe this as is the shape. Right? So with the shape, it refers to the overall shape of the distribution. Right? So is it symmetrical? Right? Is it uniform? Is it skewed? Or bimodal? Right? So these are 4 different ways of doing that. We're going to look a little bit more in depth into each one of these. Right? So now let's first start off with symmetrical data. So this refers to data in which both sides are more or less the same when the graph is folded vertically down the middle. So basically, if you just take it, slice it together, put it like a little piece of bread that you just bring together, you don't want to get another slice of bread out, so you just fold it on itself, you got yourself symmetrical data. Right? So it's the same from both ways. Okay. So a bell shape is a special type that we're going to talk about with symmetrical data later on. Right. So the bell shape's what we'll call normal distribution later on, but again, it's not quite yet what we're looking at. Right. So, but symmetrical has a central mound with 2 sloping tails. So the farther parts out, just a little bit of sprinkles off to the side. Alright. The next type of shape is uniform. This refers to data in which every class has equal or approximately equal frequency. So this is like if you were rolling one single die. Right? Each number on the die has the same amount of chance to end up getting it. So if you rolled enough of them, you should have where every single one of them should be about the same if you've rolled enough rolls. Because there's an equal chance for no matter what you're having. Right. The next one is the skew data. This refers to data in which one side tail is longer than the other. So where the symmetric was, where it tailed off on both sides, the skewed only goes on one way or the other way. Okay. You got a big hump, and then it just tapers off yours going towards either the right or the left. Right. So when we're talking about if it's going to the right or the left, that's the direction of the skew. Right? You basically say it's skewed to the right or skewed to the left. Wherever the tail is at, it's the way that it's skewed. Right? It's that simple on it. Right? If it's going to the right, then you'll say it's positively skewed. If it's going to the left, you'll say it's negatively skewed. Again, you can say skewed to the left, skewed to the right. It does not matter. Just basically you're talking about some way it tells you where that extra little bit of data goes. Right. So on these skewed graphs, because it's skewed to the right or skewed to the left, that is where it affects your center a lot. Because if you have all those extra points off to the right, then your mean ends up getting pushed farther to the right. So that's why whenever you end up having a skewed graph, you rather use your median as your center. Alright, and then the last one of the shapes, bimodal or multimodal. Right? So what that means is that you end up having a distribution of peaks in the shapes of the distribution. So bimodal will have 2 peaks, multimodal would have more than 2 peaks. But basically you end up having a big chunk over in this group and a big chunk over here on this group. Alright? So one of those reasons why you might have bimodal or multimodal is, say if you had where you were doing a test on men and women about how many sit-ups they could do, right? There could be a big difference between those groups, or probably more of a line would be like the average height people, right? And you had men versus women in the same study, right? Not really versus, but together, right? You'd have a big old max up for the average height of the men, and then the average height of the women. They wouldn't really line up together where it's the average height at the same spot. Alright, and now we're going to look at this last one, and we're going to look at here and say, what's the distinctive thing about the class J here? So if you notice here on the outside, we have these 2 points, one by 50 and one about by 85. Now those ones are special points because they're all on the outside. Those are called outliers. So those outliers are something that's unique or unusual about the graph. So examples of unique or unusual is outliers, the value that lies away from the rest of the data, are gaps, right? Are clusters. Okay, so if you have either a big space in between things or a spot where there's a bunch of things grouped together, those are all different things that are unusual or unique. But you still want to include something unique or unusual in your graphs, because that gives you the information that you need for it. Alright, so you also, the very, very most important thing about this is that you make sure that whatever you are doing with the description describes the graph in context to what you're actually talking about. If you don't actually let them know in context about what you're doing, you're going to have problems here. Okay, so you must write your answers in reference to the context in the problem using correct statistical vocabulary and using complete sentences. The W's, the who, what, where, when, why, how are all important key factors of this.